In this lesson, we're going to look at oxidation reduction reactions, also known as redox. Oxidation and reduction happen as a pair. As one species is undergoing oxidation, another is going reduction. And we often abbreviate this or shorten this name down to redox. Before we look at reactions, we need to learn a little bit more about what oxidation and reduction are. Oxidation occurs when we have the loss of electrons, and that also goes along with an increase in oxidation number because we're losing negative charge, so our oxidation number increases. Reduction is the gain of electrons and also goes along with a decrease in oxidation number because we are gaining additional negative charge. There are a couple of mnemonics that can help you remember what's going on. Leo the lion says grr, lose electrons oxidation, gain electrons reduction. Or oil rig, oxidation is loss of electron, reduction is gain of electrons. What we need to do when we're looking at reactions is identify species that are being oxidized or reduced. And before we can do this, we actually have to assign oxidation numbers to every element in the reaction. We'll start with our H2 and Br2, which are both free elements, and therefore have oxidation numbers of 0 for both. When I look at HBr, hydrogen has an oxidation number of +1, bromine has an oxidation number of -1 because the sum of the oxidation numbers must be equal to 0 for that compound. What I'm going to look at now is what's changing in oxidation number. I see that the hydrogen goes from 0 to +1. Therefore, this is an oxidation. We are losing electrons, so the oxidation number is increasing. For bromine, I go from 0 to -1. Therefore, this is a reduction, or the gain of an electron. Let's look at another example. For C2H4, we know that the oxidation number of hydrogen is +1, and we'll have to determine the oxidation number of carbon, so we'll label it X. Hydrogen is +1. 2x plus 4 times 1 is going to be equal to 0. 2x plus 4, 2x equals -4, so x equals -2. So the oxidation number of carbon is -2. Oxygen is a free element. It has an oxidation number of 0. Carbon is again X. Oxygen is -2 because it's in a compound this time. We can do the math. X plus 2 times -2 equals 0. X minus 4 equals 0. X equals +4. For water, we have hydrogen has an oxidation number of +1. Oxygen has an oxidation number of -2. And now we can look at what's happening or what change is happening in this reaction. If I look at carbon, it goes from -2 to +4. Therefore, it's undergoing oxidation. It's losing electrons. Oxygen goes from 0 to -2, and it doesn't matter that it's oxygen in two different places. What matters is it's oxygen 0 with the oxidation number, and then to -2 in the products. From 0 to -2, and that's a reduction because we see a decrease in the oxidation number. In order for it to be a redox reaction, we have to have at least one oxidation and at least one reduction, and the only way we can identify that is by assigning oxidation numbers to each element in the reaction. Is copper 2 plus gaining or losing electrons? When I look at the oxidation numbers for the species in the reaction, I see that copper goes from a +2 to a 0 oxidation number. The oxidation number is decreasing, therefore we are gaining electrons. Is copper being oxidized or reduced? We see that we're gaining electrons, therefore it is a reduction occurring. So copper 2 plus is being reduced. Is magnesium gaining or losing electrons? We're going from 0 to +2 oxidation number. It is a more positive value, so it's increasing, therefore we are losing electrons. Is magnesium being oxidized or reduced? We've already determined that magnesium is losing electrons, therefore it is undergoing oxidation. The copper is being reduced, the magnesium is being oxidized.